Welcome to clickmakeprojects.com. Here we discuss about an efficient formulation of the improved visual assessment of cluster tendency algorithm. Clusters are group of similar objects inside a population. When the population of objects is separated into several clusters, it is non-homogeneous. To perform multivariate calibration modeling, the calibration objects should preferably belong to the same population. Often this is not possible. Example, in the analysis of industrial samples, when the samples belong to different quality grades, the occurrence of clusters may indicate that the object belong to different populations. This suggests there is a fundamental differences between two or more groups of samples. Example, two different products are included in an analysis, or a shift or drift has occurred in the measurement technique. When clustering occurs, the reasons must be investigated and appropriate action should be taken. If the clustering is not due to industrial reasons that may be corrected, then there are two possibilities: to split the data in groups and make a separate model for each cluster, or to keep all of them in the same calibrated model. The advantages of splitting the data are that one obtains more homogeneous populations and therefore one holds better models. An even more general form of relation data is rectangular. These data are represented by an n-cross-n dissimilarity matrix, where the entries are the pairwise dissimilarity values between m row objects and n column objects. An example comes from document analysis, where the row objects are m pages, the column objects are n words, and the dissimilarity entries are occurrence measured of words in pages. In each case, the row and column objects are non-interesting sets, such that the pairwise relation among row objects is unknown. Conventional relational clustering algorithms are ill-equipped to deal with rectangular data. Additionally, the definitions of a clustering as a group of similar objects takes on a new meaning. There can be group of similar objects that are composed of only row objects, of only column objects, or of mixed objects. Clustering is the process of grouping the objects in a sensible manner. This process is often performed to elucidate the similarity and dissimilarity among and between the grouped objects. Clustering has also been called unsupervised learning, typology, and partitioning. Although clustering is typically thought of as only the act of separating objects into the proper groups, clustering analysis actually consists of three concise questions. 1. Clustering tendency. How many clusters are there? 2. Partitioning. Which objects belong to which clusters and to what degree? 3. Clustering validity. Are the partition good? In the VAT algorithm, it displays an image of reordered and scaled dissimilarity data. Normally, the dissimilarity data are arranged as a matrix, and each and every dissimilarity values are considered as a pixels in VAT algorithm. Each pixel of the grayscale VAT image displays the scaled dissimilarity value of two objects. White pixel represents high dissimilarity, while black represents low dissimilarity. Each object is exactly similar with itself, which results in zero-valued diagonal elements. The off-diagonal elements are scaled to the range 0 or 1. The dark block along the diagonals is a submatrix of similarity small dissimilarity values. Hence, the dark block represents a cluster of objects that are relatively similar to each other. Thus, cluster tendency is shown by the number of dot blocks along the diagonal of the VAT image. In our algorithm, we proposed an improved VAT algorithm by using a special formulation which converts the computational complexity of the iVAT algorithm from O of n cubed to O of n squared. Thus, in our proposed method, it reduces the computational complexity by using efficient formulation of iVAT algorithm. This is the flow diagram of our project. In the first step, we input the dissimilarity points. Here, the dissimilarity points contains in an array format. Then these array format are arranged as a matrix, which gives the n-cross-n size of dissimilarity matrix. Then these dissimilarity matrix are rearranged by using VAT algorithm. From the reordered VAT algorithm, we select the pixel points of I and j position. Then for each and every pixel points, we further calculate the least level of the matrix arrangement. Then for each and every iterations, we compare the first row and second row, that means previous row and present row of the matrix. By using this comparison, we reorder these pixels in a matrix and finally evaluate 2n squared minus 3n. This will generate the final result of O of n squared. Thus, we reduce the computational complexity by using efficient formulation of iVAT algorithm. Now I am going to explain the running process of our project. Now run iVAT.m file. Here it gets the input from user. In this 1, 2 and 3.dat file, this contains the dissimilarity points. Here these files are going to use for iVAT algorithm. I just gives the 2.dat file as an input. Here in the figure 1, it displays the input given points, the scattering points. In this figure 2, it displays the given input matrices, dissimilarity matrices. This shows the rearranged dissimilarity matrices into a square form. Here in this figure 3, it displays the cluster formation by using iVAT algorithm. Now I am going to compare this result with iVAT algorithm and VAT algorithm. Now I gives the comments for VAT algorithm. Here I am giving the input 2.vat. This input is given to VAT algorithm. Here I gives the commands. Here, this figure displays the result of by applying VAT algorithm. Now just compare a VAT result and iVAT result. Here, our iVAT algorithm performs a clustering perfectly than VAT algorithm. Thus, we reduce the computational complexity by using efficient formulation of iVAT algorithm. Thank you.